So coming to the second problem, a 230 by 460 volts transformer has a primary resistance of 0.2 and the reactance of 0.5, and the corresponding values of secondary are 0.75 and 1.8. So here the primary induced EMF is 230 volts and the secondary induced EMF is 460 volts, and the primary resistance R1 is equal to 0.2 ohms and the reactance is 0.5 ohms, and now R2 is 0.75 ohms and the X2 value is 1.8 ohms. Find the secondary terminal voltage. Is asking V2 when supplying 10 amperes, that means the load current is 10 amperes at 0.8 power factor, as cos phi 2 is equal to 0.8. So power factor lagging. So first of all you should write the formula. Percentage voltage regulation for a lagging power factor is I2 R0 2 cos phi 2 plus I2 X0 2 sin phi 2 divided by E2. The R0 2 is equal to R2 plus K square times of R1, and from this we can calculate the transformation ratio where K is equal to E2 by E1, and 230 by 460 means it is a step-up transformer. 460 by 230, the K value is now 2. So now R2 is 0.75 plus 2 whole square into R1 is 0.2. So 0.75 plus 4 into 0.2 is 0.8. The value which I am getting is 1.55 ohms. Similarly, X02 is equal to X2 plus K square times of X1. What is X2? The X2 value is 1.8 and K value is 2. K square is 2 square into 0.5. So 4 into 0.5. So this is X1 is 0.5 now. That is substituted here. 2 square into 0.5. 4 into 0.5. 4 into 0.5 is 2. 2 plus 1.8 is 3.8 ohms. And these two values are substituted in percentage voltage regulation. I2 R0 2 cos phi 2. This is for lagging power factor. I2 X0 2 sin phi 2 divided by E2. So the current value is 10 amperes. R0 2 is 1.55 and power factor is 0.8 and plus 10 into 3.8 into, remember, if cos phi is 0.8, sin phi value is 0.6. If you have a doubt, try in your calci. 10 into 3.8 into 0.6 divided by the E2 value. So the E2 value is 460, then multiplied with 100. So finally I got it as 7.65 percentage. That is called the percentage voltage regulation for lagging power factor. So E2 minus V2 is equal to I2 R0 2 cos phi 2 plus I2 X0 2 sin phi 2. What is I2 value is 10 into 1.55 into 0.8 plus 10 into 3.8 into 0.6. The E2 value is now this 460 minus 35.2 is equal to V2. So this value, entire value is 35.2. Now V2 is equal to 424.8 volts. This is the final answer. Terminal voltage is asking. A 230 by 460 volts transformer has a primary resistance as R1 is given, X1 is given, and R2 is given, X2 is given, and the load current is 10 amperes and 0.38 power factor lagging. Find the voltage regulation. This is a formula. Percentage voltage regulation is equal to I2 R0 to cos phi 2 plus I2 X0 to sin phi 2. This plus is for the lagging power factor. From this you should calculate the percentage voltage regulation. After that the drop E2 minus V2 is equal to I2 R0 to cos phi 2 plus I2 X0 to sin phi 2. From that you can calculate the V2 value. Coming to the next problem, calculate the regulation of a transformer in which the ohmic loss is 1% of the output and the reactance drop is 4% of the voltage. Ohmic loss, that means full load copper loss, percentage full load copper loss is equal to 1%. So as we have seen in the derivation, that should be equal to percentage R, and percentage X is equal to 4%. Then you can calculate the voltage regulation for 0.8 lagging power factor. Percentage voltage regulation is equal to percentage R cos phi plus percentage X sin phi. Plus is for lagging power factor. So substitute here 1 into 0.8 plus 4 into 0.6, 2.4 plus 0.8, that should be equal to 3.2%. And the second is for unity power factor. Second is for unity power factor. Percentage voltage regulation is equal to percentage R. The cos phi value is 1. So into 1 plus percentage X into, if cos phi is 1, sin phi is 0, that should be equal to percentage R. So that is 1% only. And the third bit is 0.8 leading power factor. So now the percentage voltage regulation is equal to percentage R cos phi minus percentage X sin phi. So R is 1 into 0.8 minus percentage reactance is 4 into 0.6. So 0.8 minus 2.4, that should be equal to minus 1.6%. So this is for 0.8 leading power factor. And this problem is very, very important, and this problem is repeated in so many times. And this is a somewhat twisty problem. And this problem is appeared in one of the GATE examination also.